Hello, everyone, and thanks for joining week 5. Ready for another exciting session? So, as usual, we have a few of the Amazonians here to help you out. We do not have Ashish and Parna today. Both of them are a bit busy, but we have other folks. So joining us today is Nisha.
Hi, everyone.
Achal,
Hi everyone.
Anmol,
Hello.
Vijender,
Hello.
and myself, Prasad. So let's get started. Let me start with a screen share, and we do have a uh, to stage, and then yes, and we do have a question for you to go for Achal. Sorry, Nisha, go for it.
Okay, all right. So thanks, first of all, everyone joining, wherever you are joining today. Let's start thanking Ashish, Prasad, and Parna for this amazing program and their amazing work. And before we dive into this today's interesting topic, we wanted to ask you a question. Whether you are joining this program or returning, we would love to hear from you. Please share one word that captured your experience with this BESA program or the team. Feel free to add multiple words but in separate comments. So share your thoughts in the chat, and we welcome critical feedback to help us improve this program and this team. So let's see what we see.
Okay, we have few comments coming in. Powerful, super, finest session, excellent. That's good to hear that everyone is enjoying the sessions that we try and add value to. Informative, free. That's true. That's one of the USP that we say. It's free. Disciplined, well planned. Very sad it's week 5 already. Oh, okay. That's in a way it's a good thing, but yeah, it's not easy for everyone. We understand to continue for 6 continuous week. So if you folks remember the first live stream when we had around 1,600 people joining, and right now I see around 300 people joining. So we understand, like, week after week it's not easy to continue because people have their own personal things going on. And even when the difficulty level rises, it's very difficult to continue. But yeah, thank you for keep showing up week after week.
Yeah.
Industry experience. Sorry, go ahead, Nisha.
Yeah, I was just going to say that please be focused. Today, we try to make today's session very simple. So if you will be focused, it will be easy and not so difficult.
Yeah. Cool. With that, let's keep moving. As usual, a bit of housekeeping. As you all know, that this batch is about agentic AI on AWS. So we started on 21st Feb. This is our 5th week that is going on. The next weekend would be the last one, that is 28th March. So yeah, time flies, 6 weeks already there. We live stream every Saturday, 3 p.m. GMT. And here is what we have covered up till now. And this week, we'll be covering in the technical track, Model Context Protocol, MCP, which everyone might have heard at least about it. It's very much prevalent for some time in industry now. And on the behavioral track, Jeff would be back again with another powerful session. With that, without wasting time, let's continue with the technical track. And I'll hand it over to Nisha and Achal to take this track. And me, Vijay, and Anmol will be there in the background helping you support on the chat.
Thanks,
Thank you, Prasad.
Yeah, thank you. So for today's session, just for this session, I will be acting as a principal architect, and Achal, who is inspiring or a junior architect, and together we will walk you through this important topic, which is Model Context Protocol. Over to you, Achal.
Thank you, Nisha. So let's get started. So Nisha, tell me one thing. We've been learning about agentic AI on AWS in the past few weeks. We have Bedrock agents, multi-agent orchestration, all of that. But one thing that keeps coming up that I don't fully understand is MCP, and people keep saying how critical it is for agents. As an aspiring solutions architect, do I need to understand this?
That's a good question. So once again, MCP stands for Model Context Protocol. So absolutely, Achal. So here is why. When a customer comes to you and they say, we want to build AI agent that actually do things. So basically query our database or file tickets or even check inventory. So the first question you need to answer as an SA or a solution architect is, how will the agent connect to all these tools? And that's exactly what MCP solves.
So it's not just a developer thing then.
Yeah, not at all. So MCP stands for, again, Model Context Protocol. It's an open protocol that standardize how AI applications provide context and tool access to large language models. We all know LLMs, all these names by now. Think of it as this way. How when we explain VPC, we use the analogy of a house with the rooms, doors, and locks. You remember?
Yeah, of course, that's one of the favorite best analogy, honestly.
Exactly. So MCP is just similar to that. It's an architecture of how AI agent open doors to the outside world. So without MCP, every door needs a custom key. So with MCP, there is a one universal key that works everywhere. It can create. It was created by Anthropic and open source late in 2024, and it's now supported by Claude, supported by Bedrock, Visual Studio Code, Kiro, Cursor, and many more.
So it's basically like a universal standard.
Exactly. So people call it a USB-C for AI. So before USB-C, every phone had a different charger. But and before MCP, every AI tool integration was custom. So now that's all one standard.
Wow, that's very interesting. But we already had function calling and tool use with LLMs, right? Bedrock agents can call Lambda functions, and hence you can use the tool. So what was broken that MCP is fixing today?
That's a great question. As an aspiring SA, I love this question. So before MCP, every integration was bespoke. If you had, let's say, 5 AI clients and 10 tool, you needed 50 custom integration. Each client had its own way of defining tool, passing context, handling responses. It was an N into M problem.
Okay, I see. And then what does MCP turn it into?
N plus M. So imagine the difference between N into M and N plus M. Each client implements the MCP client protocol once. Each tool implements the MCP server protocol once. And now any client can talk to any server. You build any tool once and it works everywhere. So in Bedrock, in Cloud, in Kiro, wherever.
So that's actually pretty powerful for a customer. Build once and use everywhere.
Exactly. So, as an essay, it's a cost optimization and operational excellence argument rolled into one. Imagine telling your customer, if you build these integration as MCP server, you won't have to rebuild them when you switch AI platform or you add a new one. And that's a future proofing their architecture.
I mean, this honestly reminds me of the well architected framework that we have designed for change.
Spot on. So MCP is just like our well-architected approach for AI integration. So for someone who is joining today, they are new to AWS, and if they do not know what is AWS well-architected approach, it is a framework. It provides a consistent approach for cloud architecture to build, measure, and manage resources, high-performing, resilient, and efficient infrastructure, which is centered around our six pillar, which we call operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability.
Awesome.
So let me give you some compelling reasons why MCP matters. So first is standardization. Before MCP, every integration was a snowflake. custom code, custom protocol. MCP now gives us a common language, and that's huge for any industry. MCP provides a standardized way for AI model to interact with external resources, which helps ensure compatibility and reduce the complexity associated with integrating different systems. Second is integration with external data sources. And this is an amazing feature. I personally like it. Your AI can now access database, content repositories, business application, anything through a standard interface. No more custom integration code for every data source. MCP enables AI models to access and utilize data from external sources, which can include database, API, and any other model also. So this integration allows model to leverage the most current and relevant information available. The third, I would call it enhanced functionality. MCP doesn't just connect to data, it exposes tools, prompts, and resources. And I'll cover those bit detail in further slides. But your AI agent superpowers through these standardized interface. So by connecting to specialized tool and services, AI model can perform tasks that might be beyond their native capabilities. So, if I have to give you an example, they can use external tools for data processing, visualization, or even human in the loop feedback. And last but not least, flexibility and scalability. So if we want to add a new data source, you can just spin up a MCP server. Want to switch to AI models? Yes. Your MCP infrastructure stays the same. It's the true modularity. MCP facilitates the development of more complex AI system by allowing models to be exactly combined with other models and tools. And this modular approach makes it easier to scale all our AI application and adapt them to different contexts. I hope this helps.
It does, it does. So basically, MCP is to AI applications what REST APIs were to web services. A game changer for how we build systems.
Mhm.
That's great. I love the value an MCP server can add. So walk me through the architecture. What are some moving pieces here?
Okay, so that's the great segue to this slide now. So let me use an analogy. As always, we love analogies. So let me use something that will stick with you. Imagine a consulting firm. The host is the firm itself, and that's your AI application like Amazon Bedrock or even a Claude desktop. It's where the client user interacts.
Okay, so that's the firm.
Yeah, exactly. So
Okay.
so exactly inside the firm you have an account manager, and those are the MCP clients. And each account manager maintains a relationship with one specialist consultant, and the specialist consultants are the MCP servers. And one consultant know database, another consultant knows ticketing system, another knows file storage, so on and so forth.
So basically, when the AI needs to query a database, it asks the account manager who calls the database consultant.
Exactly. And that's the beauty. The consulting firm doesn't need to know how PostgreSQL works internally or DynamoDB works internally. It just knows. So, I have a database consultant who just speaks to MCP, and I send a request and I get a response, and server handle all that complexity.
Okay, I see. So can you give me a concrete example with AWS services? Because then it'll help me just picture this in a customer architecture.
Sure. So let's say customer is building AI-powered IT help desk system using Amazon Bedrock agent. So our use case is our customer is building AI-powered help desk using Amazon Bedrock agent, and the host is Bedrock, and that's where the agent runs. And customer needs the agent to do three things. And what are those three things? Look up employee information, check the status of the infrastructure, and create support ticket, right? So, MCP server can expose three types of capabilities. MCP has a three core concept you need to understand. Think of these as a just the three ways MCP server can help your AI. And again, I'll just use our help desk example. So let's dive deep into the tools aspect of the MCP. These are functions the AI agent can call. The agent decide when to call them based on the user's request. And in our example, it could be lookup example, lookup employee, get service health, or even a create ticket, right? So each tool has a name and each tool has a description and a schema that will define what input it needs.
So is the description important? Because usually descriptions are optional in things.
Yeah, I would say it's not just important, it is critical because, and I will probably keep saying this again and again, but it is critical. Descriptions are critical. AI needs the description to decide when to use the tool. A bad description means agent will call the wrong tool, or it doesn't even call when it should be calling. So you as an ASA, when you are reviewing your customer's MCP server design, always make sure the tool description, they are as important as our code. So good description tells the agent three things: what the tool does. So look up employee detail by alias or name, when to use it. So, for example, use when the user asks about an employee's team or manager or even contact information. And third, what it doesn't do. It doesn't return salary or performance data. So, things like that. So, bad description causes the real problem. And here is a concrete example. So, you have two tools. One is get service health, and when you describe as check service status, or when you have a tool which is actually creating ticket and you just describe as create ticket, if user says lambda is down, help me report it, right? So agent need to decide, do I check the health first, or do I create a ticket, or just create a ticket, and then the description guides that reasoning. So if get service health says use to verify current operational status before escalating it, so agent knows to check that first. If it doesn't, then agent might skip that straight to the ticket creation without confirming that's actually an issue. So you as an SA, when you are reviewing customer MCP server design, treat tool description like AI documentation. And they are the contract between developer's intent and the agent behavior. And vague description lead to unpredictable agent behaving what we do not expect it to behave. So precise description lead to reliable ones. I hope, I know I talked a lot, but I hope it all makes sense.
No, I did. I'm just trying to wrap my head around the importance of description field when it comes to tools. So this is about tools. So what about resources?
Yeah. So resources, think of them as a data for our agent. The agent can read, but application controls when, right? So think of it as a reference material. So in our help desk example, maybe there is a resource that provide the company's IT policy document or a network topology diagram. Application might automatically include these in agent's context when a relevant conversation starts.
Okay. So the agent doesn't decide to read a resource on its own.
That's correct. Application or the user decides that. Resources are just like putting a reference book on the consultant's desk before meeting starts.
Okay. I guess that makes sense. Then what about prompts?
Yeah. So prompts are reusable template that user explicitly selects. The ticketing server might expose a prompt template which is called like incident triage that structure the conversation, describe the issue, what's the impact, when did it start, who is affected, the user picks the template to start the structured interaction.
Okay, I see. So to summarize,
Mhm.
these are the agents to act, or for the agents to act. Resources are for the app to provide context, and prompts are for the user to structure conversations.
I really like how you summarize it. So it's a perfect summary. Each has a clear control boundary, and that's matter for security, which we'll get to it.
Got it.
Yeah. Okay, so now let me walk you through how a request actually flows through the system. This diagram, which you see in the screen, it shows the end-to-end workflow. When a user sends a message, says, "Is the payment service healthy?" The host passes that to our LLM or large language model along with the list of available tools from all the connected MCP client, and LLM reads the tool description and decide which tool to call. It sends the tool call request back to the host.
Okay, and then does the host route it to the right MCP server?
Exactly. MCP client forwards the request to the appropriate MCP server, and the server executes the function, retrieves the data, and sends the response back to the chain. LLM then task that result and formulate a natural language response for our user.
Okay, so the LLM then never directly talks to the MCP server, right?
That's right. That is very important to understand that everything flows through the client and the host. The separation is important. It means the host control the flow and can enforce permission, log request, and even human in the loop check before anything executes. So, as an essay, this is the diagram you would draw on a whiteboard to show customer when control points and security boundaries sit. So it will help them understand the entire end-to-end flow clearly.
So basically, the host is the control plane. It orchestrates the flow, enforces security, etc., and the LLM never directly touches the MCP server.
Exactly.
Okay, I see. So I think I understand the flow now and how things work, but how do they actually communicate between each other? Is it HTTP?
Okay, so it's not just HTTP. There are two ways. The first is STDIO, which is a standard input output. Host launches the server as a child process on the same machine, and they talk through the STDIO and STD out. Think of it as a consultant sitting in the same office.
Okay, so what about the second one?
Yeah, second is a streamable HTTP with a server sent event. And this is the remote server. The consultant is in a, let's say, different city. You will still call them over the internet. And this is what you would use for shared service that multiple users or agent need to access.
So since both are good options as a solutions architect, when would I recommend one versus the other?
Yeah. So STDIO for local, single user tool, a developer's file system, a local database, or even a Git repositories, and HTTP for shared enterprise services, centralized knowledge base, a team's internal API, anything that needs to be accessed by multiple agent or users remotely. In a customer architecture, you will often have both.
Oh, okay, I see. Got it. That makes sense. So STDIO for local single user tools, and you have HTTP for shared larger enterprise services. And
Mhm.
like you said, most customer uses both. So it depends on what the customer is using and how you want to do it. There's no one set answer here. That makes sense. So I think I understand how they communicate with each other. So walk me through some key concepts. What actually happens at each step?
Okay. So let's break it down. We spoke a little bit about tools and the importance of all the description field earlier in this section. And now let's talk in detail about the end to end life cycle here. So, first is the tool discovery. When an MCP client connects to your server, it asks, what tool do you have? And the server responds with a list saying each tool has a name, description, and input schema. And this happens at the connection time, so the host always knows that it is available.
Okay, so now that it has a list of the tools, the next step is tool selection.
Yeah, that's where our LLM shines. Based on users' request and the tool description, and I repeat, based on tool description, the model decide which tool or tools, several tools to call. And this is why descriptions matter so much. A vague description can lead to a complete wrong selection.
Absolutely. It makes sense now. So, what about function calling and result processing?
Yeah. So once LLM selects the tool, it generates a function call with the required parameters. An MCP server execute it and return the result. LLM then process that result. It might be directly, or it might chain to another tool based on what it has learned in the past.
Oh, okay. And then the response generation, I'm assuming, is the final step here.
Yes, that's correct. LLM takes all the result and synthesize a natural language response for the user, and user never sees the raw tool output. They just got a coherent answer, which we usually see when we use all these tools.
Okay, I see. And what about testing? I see that you have three options here. How do you validate that all of this works?
Yes, as you said, three levels. I would say standard testing. Test each tool in isolation. Does it return the correct output or a given input for the given input? Second is integration testing. Test the MCP client server communication. Does the protocol works? And last but not least, the natural language testing. Test with the actual user queries. Does the agent select the right tool and produce the good response? So as an SA, you are reviewing the customer's MCP implementation. Ask them all of these three testings.
Okay, got it. So as a solutions architect, I need to make sure that they're doing covering this from all angles. That
Correct.
makes sense.
Mhm.
So what this is, I like you mentioned, right? The it can use multiple tools as well, etc. So and I understand the workflow as well. So what happens when a user's request needs more than one tool? Like, is there something that spans multiple MCP servers?
Okay. I really love your question. So that's where it really gets interesting. And folks, please be focused here. Let me give you one practical example. Say a user asks, schedule a team lunch uh, outside the next week if the weather is good, right? It's very simple question. So that single request requires multiple MCP servers working together. AI agent breaks it down. First, it calls the weather server to get the 7-day forecast, and then it calls the calendar server to find available lunch slot, and then it checks if the team is available through the same calendar, invite. And finally, it combines all that information, picks the best day, and create the calendar event.
Oh wow. So it involves three different the weather, the calendar, and then you have just finding the available time slot. So are you saying that the agent figures out all the orchestration on its own?
Yes. That's when the LLM handles the reasoning. It looks at the available tools, understand the dependencies between them, and then it calls the right agent in the right order in the correct chain. Agent knows it needs the weather data before it picks a day, and it needs availability before it books a slot, and not vice versa, right?
Okay, got it. So as a solutions architect, when I'm designing a multi-server architecture, I need to think about how tools across different servers might need to work together. It's not just individual. So individual, of course, but we also need to understand how these work with each other.
Exactly. And that's where a good tool description becomes even more critical, that I mentioned earlier. The agent needs to understand not just what each tool does, but how they relate to each other. And this is the kind of orchestration design that customer needs in SA guidance, and they relies SA to guide on all these details.
Okay, I see. Okay, that makes a lot of sense. So I think I understand how tool works and what are the different kinds of testing available for these tools. And now we see how these multiple tools work together. So what if I want to build an MCP server? What are some key steps involved there?
Okay. Key steps, you ask 5 things. You need to get it right. First is a server creation. You instantiate an MCP server with a descriptive name. The name helps with debugging and show up in the log. So make sure that it is meaningful.
Okay, so that's about first you start by creating the server. What about the next step, tool registration?
Yeah, this is where you define where your server can do, and each tool needs a name. Again, clear description, input parameter with different types, and the actual implementation. The description is important. It's what AI needs to decide when to use the tool. A good description tells the agent that the tool, what the tool does, and when to use it, and what it doesn't do. Like, 3 questions that we covered earlier.
Absolutely. It looks like the description field is truly very important in this. So, what about the next step, error handling?
Essential, I would say, because your tool will receive unexpected inputs, as we should always be prepared for not expected, all those edge cases, and when you hit all these edge cases, external service will fail. So good MCP server validate input, handle those errors gracefully, and return a clear error message, so that agent needs to understand what went wrong, and it can recover or inform the user, so that error message should be should be clear too.
Okay, got it. So, you need to factor that in as well while building an MCP server. That makes a lot of sense. And now, testing?
Yeah, you again test at multiple level. Unit test your tool functions directly, test your server's protocol handling, and test end to end with the actual MCP client to make sure that everything integrates correctly.
What about debugging when things go wrong?
Yeah, you just need to add logging from the start. Log everything, like every tool invocation, what was called, and which parameters were used, and what was returned. And when an agent behaves unexpectedly, those logs are how you would trace what happened. And in production, this also gives you the audit trail you need for your compliance or even auditing report, which we should always be prepared for.
Got it. And honestly, as a solutions architect, this order makes a lot of sense.
Mhm.
We have start by creating the server, then you register those tools with good descriptions, and you have to factor in the fact that it needs to be able to handle errors, test thoroughly from end to end, and instrument for debugging as well.
Yeah, that is exactly right. That this pattern applies whether you are building a simple utility or even a complex enterprise integration. So this concepts will always remain same.
Got it. That was very insightful. So I guess now we've seen what are the steps involved in building your own MCP server. How do I factor this in an AWS architecture? And we're just talking about AWS here. Why would I want to? What kind of services can I use with AWS architecture, and what are some advantages with it?
Okay, glad that you asked this question at the right point in time. But again, I would like to call it out that there are several patterns that you can use. You can solve a same problem different ways. But just for our conversation today, I'm just going to use this production pattern. There are some key advantages of using the Lambda function, and I will use that. I will use a serverless architecture, You do not need to manage infrastructure when you are using serverless architecture. Lambda handles scaling and availability automatically. It is also event driven. So, Lambda function can be triggered by various AWS services, making them ideal choice for MCP server implementation. It is also cost effective. You only pay for the compute time that you consume. And integration, again, Lambda integrates seamlessly with all our AWS services like API gateway, S3, DynamoDB, and you can look into our documentation. There are a bunch of integrations, right? So you can use Lambda function to integrate any of our AWS services.
Yeah, Lambda is honestly one of my favorite services. So I know that in the past 4 weeks with Pesa, we've been learning about Bedrock Agent Core and other services that we've been using. So how does this work with Bedrock? We learned it in the last session. We wanted to understand the differences between how it integrates together, if it can.
Okay, so you want to understand how it works with Bedrock. Okay, so Bedrock Agent Core lets you deploy MCP server as a remote endpoint using AWS Lambda or even a container image. So instead of a local subprocessor, your MCP server runs as a Lambda function, and that the Bedrock agent calls over HTTP. Same protocol, same tool definition, but now it's serverless and it is scalable. We talk more about production deployment with Agent Core last week, and I recommend everyone to go through that video if you want to dive deep into that. But for now, let's just talk about our important difference between deploying on Agent Core runtime versus Lambda. So Agent Core Runtime is it's purpose built for MCP server. It natively supports the MCP protocol with streamable HTTP and automatic session management. We can also call MCP automatic session management. It is also stateful session. It maintains a session state across multiple calls with up to 8 hours per session with complete session isolation. It also handles manage infrastructure because here you do not need to configure your ECS cluster, load balancer, or auto scaling. AWS handles everything for you. And true consumption pricing. So CPU build only during active processing and not during IO wait like LLM response. And memory is built for session lifetime. And if we talk about built-in authentication, it is also integrated with Azure Core Identity for either it is OAuth 2.0 or even IAM 6v4. And if you want a quick deployment use, you can use Agent Core Configure or Azure Core Launch commands to deploy from the source code. So that's all about Agent Core runtime. But since we are talking about Lambda, it's general purpose serverless and not MCP specific. So you require manual MCP protocol implementation. It is stateless and there is a 15-minute maximum execution time for Lambda. We all know we should always factor in that. We should always consider that because each invocation starts fresh with no memory between calls. And manual setup required. Requirement is no longer there because you need to implement JSON RPC method. You can configure API gateway, you can handle authentication, and even manage error response. And for session limitation, no built-in session stickiness. It's not ideal for long-lived MCP server that needs a persistent connection. And stateless operations like web searches and API call with a single request response pattern. I talked a lot, but I hope it all makes sense, Sachal.
No, it does. That was a lot of information. So basically, in summary, when should I be choosing one over the other?
Yeah, okay. So let me summarize it. So choose Agent Core Runtime when you need a stateful multi-turn conversation. Your MCP server requires long-running task which is beyond 15 minutes. You want minimal infrastructure management, and you need enterprise-grade authentication and observability. So is that clear for Agent Core, Achal?
It does make sense, yes.
Okay, so for Lambda, you have a simple stateless MCP operations. Your task complete quickly, which is under 15 minutes. You want to leverage existing Lambda infrastructure and cost optimization for intermittent or even short duration workload. So that's
Okay.
the summary for Agent Core and Lambda.
Got it. So this is one of the recommended production patterns, then Lambda-backed MCP servers behind Bedrock agents.
Yeah, that's right.
Oh,
Okay, so that's one of the most common pattern, yes, and it's a great architecture to recommend because it gives you serverless scaling, IAM-based security, and CloudWatch observability out of the box. So
okay.
all connects together.
Got it. That makes sense. But as a solutions architect, honestly, let's talk about the elephant in the room. We're giving AI agent access to tools that can read databases, create tickets, modify systems, look at performance reviews with the help desk example that you took, etc. And that sounds extremely risky. Can you talk a little bit about security here?
Okay, so let me. Okay, I think. Okay. It absolutely requires careful thought, Achal, because this is where you add an enormous value. Let me walk you through those key principles. First, always comes first. At AWS, we call security is job zero. Always think of principle of least privilege. So you only provision what you need. Each MCP server should only have access to what it needs. The ticketing server agent gets Jira access. The monitoring server gets CloudWatch read-only access. They don't need to share credential because they don't have cross access.
Okay, so that's like IAM roles for Lambda functions.
Exactly. Same principle applies there. So, in fact, when you deploy MCP server as Lambda function behind Bedrock, you literally use IAM role to enforce this. And each Lambda gets its own role with only the permission it needs.
Okay, I see. So what about AI making bad decisions about when to call tools?
Great point. So that's when human in the loop comes in. Good architecture shows the user what tool is being called and with what parameter being executed, especially for destructive operations, creating tickets, modifying records, deleting anything. The user should confirm, right? So that's when user in the loop should come in.
Okay, I see. And what about prompt injection? Someone puts malicious instructions in the data that the agent reads.
It's a real concern. So MCP server must validate all input. Do not trust that your AI will always send well-formed requests. Never assume that. Always sanitize your input. Use a parameterized query for database. Never construct shell commands from raw AI input. Output, sorry. And this is the same security hygiene we teach for web application. It's all the same logic. It also applies here for the AI too.
Are there any other security best practices?
Log everything. I would say log everything because at some point someone will always come and ask you what are my invocation, where how can I see what went wrong when, right? So every tool invocation should be auditable. Who calls what when with which parameter. So in AWS, AWS CloudWatch and CloudTrail gives you this, and keep these servers focused, one server per domain. A mega server that does everything is a security nightmare. So, and an operational headache. So just make sure to log everything.
Got it. So what about some real life scenarios? When would be an ideal time to bring up MCP with a customer?
Okay. I would say there are three scenarios that come up constantly, and I always use them. First, customer is building agentic AI from scratch. They want there are customers who are just starting from building agentic AI from scratch. They want agent that query database, file tickets, check inventory. You design the MCP server architecture and what server, what tool each exposes, how they are deployed, how they are secured, everything. So that's the first thing.
Okay, there's a greenfield case. What about the second one?
Correct. So the second is they are already using Amazon Bedrock Agent with Lambda functions for tool use. So they have familiarity with the Amazon Bedrock Agent. In that scenario, MCP gives them a standard interface. Instead of custom Lambda integration, they wrap their function as MCP server. Now these same tool work with the Bedrock, with the Cloud, with any MCP client, and adding new tool becomes just a plug and play.
I see. And what about the third one?
Third one is actually future proofing. AI landscape is moving fast. You know where we were 5 years back and where we are now. So AI landscape is moving fast. Customer who builds custom integration today will have to rebuild them when they adapt a new technology or a AI platform. A customer who builds MCP server has has those portable tool, and that's the powerful architecture argument, right? Especially for enterprise that are evaluating multiple AI providers, which is the very which is the case all the time.
Got it. So this connects to what we discussed last week about the SA in the age of AI. The AI can generate the code for the MCP server in 90 seconds, but deciding which servers to build, how to scope them, how to secure them, and how they fit into the customer's existing architecture, that would essentially be our job.
Perfect. Yes, you said it correctly. So remember the two bucket. MCP server code is in the AI can do this bucket, and architecture decisions are firmly in the requires human judgment bucket. So that's your value as an
Got,
SA.
got it. So is the only way to create your own MCP server? Like I would like to make use of some of these, but just it just seems like a lot of work. So what are some options that I have?
That's a great question. You do not need to start from scratch for everything. A lot of these things are just a web search away, to be very honest. And as of as of today, over 1,000 community MCP servers are already available on GitHub or NPM, and even some official SDKs for Python, TypeScript, Java, C Sharp before building these custom servers. Check. So I would say check if one is already exists for the common use case like database. If there is a Postgres database, MySQL, DynamoDB for storage if you have a file system, S3 for development tool like Git repository, collaboration platform like Slack, Jira, or even AWS services, right? So make sure to check that if something already exists.
Got it. And this is a relief, honestly, to know that all of these resources already exist. So, can you give me a framework I can take into customer conversations?
Okay. So I would say when you want to do that, I would always keep these 6 questions in mind. Ask these whenever a customer wants to build agentic AI application. First one is what tool and data sources do agent need to access to? And this defines your MCP server inventory, correct? The second is what are the security and compliance boundaries? Whether they have a HIPAA, GDPR, PCI, or even FedRAMP, right? So these determine how you scope access and which tools can see what data. Third, should tools be local or shared? So developer tools might be local, STDIO servers. Enterprise services should be remote HTTP servers. So those are the one. Fourth, how will this MCP server be deployed and scaled? Lambda for serverless, container for long running process, or maybe sometimes a mix of both, because lambda server has 15 minutes constraint. That's when you have to consider using containers. Fifth is what happens when a tool fails. You need error handling, you need a fallback mechanism, maybe a circuit breaker, so that if, let's say, model doesn't respond, tools should not keep calling it, and it should stop calling it for a moment, unless that becomes available, correct? And you also need agent to gracefully handle those tool being unavailable. So that's when either they will respond back user with a graceful error message, or they will not just give them 503 or some kind of an error. And last but not least, the sixth one, who approves this destructive action? Creating records, modifying data, deleting resources, all these needs human in the loop confirmation. So these are the 6 questions I would always ask. I hope these are very concise, clear, and not complicated questions.
No, this is a solid framework. So basically, that's a lot of information that we covered. So MCP is the standard protocol that lets AI agents connect to tools and data. It essentially has 3 layers: host, client, and your server. And it has 3 primitives, which is tools, resources, and prompts.
Mhm.
I don't need to code MCP servers, but I do need to understand the architecture so I can design secure, scalable agentic platforms for my customers. And on AWS, the recommended production pattern would be with like Bedrock Agent Core. You can use Lambda packed MCP servers, etc. And I'm sure there's a lot of other information out there about it too.
Mhm.
And now I have the 6-question checklist as well for it to be a starting point for conversations. That's truly awesome.
Yep. Okay. That's a great summary. Thanks, Achal. So MCP again is a standalone protocol that lets all the AI agent connects to tool and data. It has all the 3 layers, and you summarize it well. And I would add one more thing, Achal, that this is the future of how all the AI systems will integrate with the real world, right? So you as an SA who understand MCP today will be the one leading these agentic AI engagement tomorrow with all our customers. So it's like understanding VPC back in 2015. It seemed niche then, but now every architecture conversation starts with AI, agents, agentic flow, and so on and so forth, right? So this is the one thing I would say, that keep that in mind.
Got it. So basically, MCPs are very powerful. We just need to understand how to use them properly and which ones are safe.
Yep. So that's when SA will design, and you will shine and give all your um, guidance to our customer. So, Achal, here are some of the resources that I would always share with you or any customer. You can, if you are interested, diving deep into MCP. So please go look into all these resources. Achal, thank you for asking me all these questions. So this was very helpful. Thank you, Achal.
Thank you, Nisha.
That's amazing. Thank you so much. This is the first time in VESA that we have been able to complete before time. So thank you so much into the time. Otherwise, always we are scrambling in terms of covering the topic within the time. So thanks, Nisha, and thanks, Ashil. There were a lot of questions, and Anmol and Vijender has been answering them as much as they could. But we understand that we might not have been able to answer all the questions. So let's continue the discussion in the Discord channel. What Nisha and Achal has covered conceptually what MCP is and how you can get started. In terms of practical, that's what we will cover in the workshop where we will be actually doing the hands-on workshops on MCP. Anmol would be showing, getting you started, and we have already recorded the workshop video, which will be live in some time. But now let's see if we can get to the behavioral section. So I see Raj and Jeff already here. So I'm going to add them to the stage. Hold on.
Hey, Raj, I love your t-shirt.
Thank you. Never miss a chance to use the AWS t-shirt.
I know, right?
It's now when you talk about t-shirt, I see that Nisha, you, me, and Achal, like we all feel like kind of wearing this stripes today. I don't know, but yeah.
Hey, Jeff.
Okay,
Good morning, good afternoon, good evening, everybody.
Hi.
Hey. Hello.
yeah.
I didn't get the memo about wearing the Gen AI t-shirt today, I guess.
Never miss an opportunity for AWS t-shirts. So.
Raj
We
didn't
got
say
enough.
Hey,
We
I
got
planned
enough of
this
them.
thing, I planned well.
And now, like all the sessions that Jeff has been taking along with Raj and other folks on the behavioral section, Jeff has compiled in our Notion page, and we have shared the Notion page both in the email and as well as the Discord channel, which includes the PowerPoints, the prompts, and everything. So, in case if anyone wants to dive deep, feel free to do that. And with that, we will hand it over to Jeff and Raj. Seems like you folks will have 5 minutes extra today to talk about behavioral section, the favorite of everyone
Awesome.
in this.
Thank you so much.
Thank you, Anchal. Thank you, Nisha.
Thanks.
Yeah, thanks, Nita. Thanks. And Prasad, I'll get that Notion page updated today with the prompts and the slides from today as
Yeah,
well.
so we'll have that one Notion page and we'll keep updating it every week. So
Yeah.
thank you so much for doing that.
Perfect. Welcome, everyone, to week 5 of our behavioral topic on becoming a solution architect. Today, we're going to be focusing on AI-powered solution validation and optimization. We'll be continuing to build upon the conversations that we've been having over weeks 2, 3, and 4. I'm happy to be partnering again with my colleague, Raj. He was here for week 2, if those of you remember that. To refresh everybody's memory, I'm a principal SA here at AWS, focusing on modernization, and also spend a lot of my time mentoring people inside AWS around becoming a solution architect. Raj?
Yeah, I'll do a quick intro. Hey, everyone. My name is Raj Menon. I've been with AWS for close to 6 years now. I'm a principal customer solutions manager.
Awesome. So today, we're going to be going through a scenario. Raj will at least be playing the roles that we play inside the company. Raj is a customer solution manager. He's been with this particular customer for 18 months now, and he's interested in learning how we can use AI in the process of accelerating work that we have with them. I'll be playing, my typical role, solution architect. I've been using AI tools now for the last 6 months to help me in the design, the analysis of architectures. And today we're going to take the next step in terms of using these tools to help, validate what we're doing and how we might optimize it based upon things that I'm going to learn from Raj based upon what he knows about the customer. We will be going interactive within our AI agent. And for those of you who need information on that, week 4 on the Notion page has the information about how to get that set up. All right, whenever you're ready, Raj.
All right. So Jeff, I've been thinking about a conversation last week on rapid architecture design.
Mhm.
You showed me on AI how to create architecture proposals in days instead of weeks. But I'm just a little concerned about a couple of things.
What's that? What are you concerned about?
So one thing, speed is great, right? Impressive what AI can do, but how do we ensure quality, right? When we're moving this fast with AI assistance, right? How do we know the architecture we are proposing are production ready? How do we catch problems before customer does?
Yeah, I think that's the most important question. And it's exactly the kind of things we need to talk about today. AI can generate architectures quickly, but it can also generate architectures that look really good on paper and fail in the real world. And this is why validation is the most critical skill for AI augmented solution architect. I would never present an AI generated architecture without putting it through a rigorous framework. And AI can give me that first draft, maybe it's 70, 80% of the way there, but there's work to do. And I kind of, call it like the right architecture. AI can absolutely help accelerate on that technical fit of what we're doing, but only through working with you can I really understand how does this architecture fit in the environment, politically, economically, feasibly, and functionally. And, so today we'll go into validating, definitely on the technical side, but also a little bit on the political and the economical side of things. And I'll kind of give you a little teaser on the other stuff. So my job's to validate, refine, and ensure that it's right for the customer.
No, completely agree. Those elements are important. So why don't we do this? Can you show me what it looks like? Can you walk me through a validation process?
Yeah, absolutely. Perfect example. Let me show you how I'd, approach that in the 4 key areas: security, compliance, reliability, and resilience, as well as cost optimization. Each area requires both AI assisted and human judgment.
Yeah. So can you? So let's take an example, right? One we both know, tech retail's e-commerce platform. Can you walk through that validation process?
Yeah, absolutely. Let me switch over to sharing my tool. I realize that this is probably not the most readable. I'm sure Prasad will let me know if this is not readable, but hopefully you can see this better. So the first thing that I would do, Raj, is, let's start with security and compliance, because this is where mistakes can be catastrophic. And for tech retail, we know that PCI compliance for payment processing is going to be super important. So, here's a prompt that I may use. And what I've done is I've already, prompted my agentic tool here to, read through the architecture that we created last week in the architecture diagram. So it's already got that in memory now from the knowledge base. And we're going to go through the prompt here. So here's the first prompt I'll use. Review this e-commerce architecture for PCS, DSS compliance, look at things like API gateway, Lambda functions. I won't read everything here. And I'll let it go off and do its thing.
What does it find?
Yeah, AI is excellent at pattern matching against, known security frameworks. It flags things like missing encryption at rest on DynamoDB, no network segmentation for cardholder data environment, missing audit logging, and potential sensitive data exposure in Lambda logs. Valid concerns, and here's where my judgment comes in. I prioritize these based on 3 factors: regulatory requirement, business risk, and implementation complexity. For PCI or requirement encryption and network segmentation, these things tend to be non-negotiable. Audit logging for compliance evidence, Lambda log sanitation is a best practice, but I wouldn't say it's necessarily like a blocker to go live.
So you're triaging these findings based on what you know about compliance and what I know about customers' risk tolerance. Is that correct?
Yeah, exactly. And you can see over here, what it created in terms of like the executive summary. So I get the, the different errors: critical, high, medium, and I really have to go through these. So here's where the customer knowledge is available. Like, TechRailer's CTO, Dave, he's risk adverse. This tells me to be conservative on security, implement more controls rather than fewer, even if they add a little bit more cost or complexity.
Yeah, agree. So now we've looked at the security aspects. What's next?
Mm-hmm.
Yeah, go ahead.
So after that, I usually validate for reliability and performance. And this is where architecture handles the actual customer workload.
Yeah, I mean, that's important, because I remember the conversations they mentioned that they get 3x traffic during holiday sales. So can you do that? Can you validate the architecture for that kind of load?
Yeah, absolutely. So, here's kind of a prompt I might do. Analyze architecture for scalability and performance. Normal loads 50,000 orders per day. However, let's test this against peak load, like 150,000 orders per day during holidays. Look for things like bottlenecks. Where might they be single points of failure, or maybe scaling limitations?
Interesting. And what does the tool tell you now?
So it might identify things like DynamoDB without auto scaling configured, RDS hitting connection limits under peak load, Lambda concurrency throttling, and like where might I have things like no caching layers. At 150,000 orders per day, we're looking at roughly 2 orders per second on average, with spikes to 10 to 15 per second. Lambda handles that easily. However, RDS connection pooling becomes critical. We need to ensure that our Lambda functions aren't exhausting database connections. This is where I validate AI's concerns with actual numbers. And as you can see over here, all the different information that it gave me about that. And it calls out things like different bottlenecks. I just kind of mentioned the RDS one. And I can go through all these to kind of see which ones that really.
Hey,
So this is where I
did I lose-
validate AI's concerns with the actual numbers.
Got it. Hey, that was a little bit of a blip. Hope you can hear me now. But no, this is great. So one thing, right? Knowing tech retail well, they're a regional retailer, not a global retailer like Amazon. So they can definitely tolerate a few hours of downtime for disaster recovery. So I'm thinking multi-region deployment would be an overkill and really expensive for them, right?
Yeah, absolutely. And that's like the perfect example of the kind of insight that I can only get through you. And that shapes the architecture. So, I talked before about the fit. Technically we're getting answers here around what's good and what's well architected. But I kind of talk about like the feasibility, the economic, and the political, So like you said, AI gives me the best practices, for multi-region maximum availability. But you gave me the business reality. Single region, but multi-AZ is sufficient. That means we can save money and the complexity by right-sizing it for where they are. Like you said, they're not Amazon. Now let's talk about cost. To me, one of the most powerful ways that I use AI to generate initial cost estimates for architectures. It can be incredibly fast and really gives us a baseline to work with.
Yeah, can you? This is a common question we get from all our customers. So can you? How does that work in the tool?
Yeah. So to me, this is a place where it saves me a lot of time. So here's an example prompt: generate a monthly cost estimate for this e-commerce application. The different components that are involved. I mentioned kind of the 50,000 load per day, and it's going to go do its thing. And to me, this is where I think to me it's a big time saver, because what it's doing is this is actually going against the AWS pricing MCP. It's getting the price in real time and pricing it based upon the architecture and the characteristics that we just gave it.
Nice. That's interesting, but that's a lot of calculations, and AI tool can do all of that.
Yeah, it's remarkably accurate for the purposes that we have here. And like I said, it's going against the actual pricing API that we have out there through the MCP. So it'll come back with things like API gateway, $175, the cost of the Lambda, and then it'll even, break it down for me by solution architect component, and scroll all the way down. I get the cost summary, which is an amazing time saver work for me. And it even comes up with some recommendations where I could maybe do things that might, help switch it to some lower cost type of things, which is, amazingly helpful.
See, that's a lot lower than I expected, right? What are the big cost levers?
Yeah, let's take a look at the database choice. AI shows that Aurora would cost, roughly, 250,000 a month versus 120,000 for RDS PostgreSQL. Like that's double. But what does that buy us? Better performance, automatic failovers, multi-availability zones, easier scaling. For tech retail, the question is, do they need that?
Yeah, so being a regional retailer, they do, I think, about 50,000 orders per day. So I don't think they need Aurora's premium features, right? What do you think?
Probably not, right? And again, this only comes through the conversation with you and what you know about the customer, right? By being able to move from, Aurora to Postgres here, that could be $120 a month savings. That's $1,400 a year just by right sizing the database choice. And they're not losing any technical or functional capabilities here. So AI gives me the options and the cost implications. You give me the business context to make the right call.
Yeah. So if I understand this right, this is not just about finding the cheapest option. It's about the right balance between cost, performance, and business constraints, right?
Yeah, exactly. And what I had mentioned before, instead of saying like, here's the right architecture, we can present options at different price points and explain, what the team, what the customer gets at each level. AI helps me generate those options quickly. And then you and I together frame them in terms of tech retail's business priorities.
Yeah, makes sense. Now, again, sorry for being paranoid. Again, here's another concern now, right? I understand that we validated this architecture for security, performance, and cost. But when we present this to the leadership team, David's going to have his entire technical staff in the room, right? They're going to challenge everything. How do we prepare for that?
Yeah, I think you and I talked about it earlier in our conversation as we were kind of leading up to this, is you got to be able to defend this in that room full of skeptics. And you're right, David is going to fire questions. And from my experience, once he does, so's his staff, and we got to be ready for that. So that's the right concern. The best architecture doesn't often fail because it's technically wrong. It's really because we didn't anticipate the questions that matter most to the customer. And this is where AI can really help me, because I can use AI almost kind of like against what it did for me. I can ask AI to be the critic of what it is that you and I have put together in partnership with our agentic tool.
What do you mean?
Well, I can ask AI to challenge the architecture from different perspectives. So, here's a prompt I might use. I'm telling the agent here, you're a skeptical CTO reviewing this e-commerce architecture proposal. Generate the top 10 hardest questions that you might ask to challenge this design. Focus on business risk, technical feasibility, operational complexity, and hidden costs.
And you have AI generate those tough questions for you?
Absolutely. It might come back with, what happens to your order processing if AWS has a regional outage? Do we lose all those orders? You're proposing Lambda for order processing, but what if our team has no serverless experience? What's the learning curve and risk? The architecture assumes 150,000 transactions per day at peak. What if we're planning a major marketing campaign that can drive 300,000? Will this scale? These are exactly the kinds of questions that David might ask us.
Okay, now let me guess, you're going to use AI to prepare answers for that too?
Yeah, absolutely. So as you can see here, it gives me the top 10 hardest questions that he might ask. And, what I like about this is it's the question and kind of like, what's the intent behind the question? Like, what am I really asking? And then how do I need to think about, preparing my answer? And also, what's an unacceptable answer? Like what's going to probably just, dig the hole, deeper that I might already be in to kind of defend this kind of thing. And I can, re-prompt and go back and forth to the questions here to really kind of get, all those kind of things that might be challenges or might be kind of critical questions to come out before we go in there.
Okay, and curious, what does AI suggest here now?
Yeah, I use AI to, help develop responses, but I validate them against reality. So like, here's a little something. So I'll kind of go on to the next one here. So we got all the answers, but one that might be a little hard hitting is this. What about the regional outage concern, right? David could ask about that. Explain the risk, quantify the likelihood based upon AWS SLA history, and propose, migration options and cost implications.
So you're not just answering the question, you're giving them options with real numbers.
Yeah. So in this case, like AI is going to quantify the risk. AWS outages are rare. Historically, 1 to 2 year, typically resolved within hours. This gives me things like options A, it might be accept the risk, estimated downtime 2 to 4 hours, lost revenue, maybe $10,000. Option B, multi-region failover at $800 a month. I know they're not, Amazon big, and we kind of, negotiated down multi-region, but maybe for the extra $800 a month, they're saying, you know what, I want to buy into that so I can reduce downtime to minutes, but, might add, operational complexity. Or option C, introducing queuing with SQS at $20 a month into the architecture. Orders are buffered during outages and processed when service recovers. No lost errors. No lost orders. So you can see here, how it starts to think through, what do we mean by regional outage? Like what could fail? Kind of what's the impact? The likelihood and what we might get, impacted by. It really gives me a lot of data to kind of have that conversation around how we might, change the architecture based upon that. So really it's kind of getting to how could we give them options so that they can have, no lost orders or minimize the amount of lost orders, based upon the economical feasibility of where they are right now.
Yeah, no, that's a complete picture, right? It's not just architecture, right? We're presenting a well-defined architecture with typical questions, right, from a technical team.
Yeah. So, and that's really the goal. And when David asks a tough question, we have to be thoughtful, and be ready to answer it. We build credibility there when we're ready to be answering these questions. And AI helps me anticipate those questions, and you help me tailor the answers to those questions that matter most, for that customer. Kind of really getting back to the fit. It's can't just be technical, but it's also got to be political, economical, feasible, and functional.
Mm-hmm. Yeah, sounds great. But again, just being paranoid or just thinking 2 steps ahead, right? How do you know these recommendations are good? What if, right, it doesn't work or isn't really secure?
Yeah, that's the most important question. And it's really where, my expertise as a solution architect and me working with you is the most critical. I never blindly trust AI output. I have a validation framework I use for every AI generated recommendation.
Nice. Can you walk me through it?
Yeah, absolutely. It consists of 5 checks. First, the context check. Does AI understand the full business context here? Do I understand the full business context and I can explain it to AI? AI might recommend a cutting edge serverless approach. However, if the customer team isn't ready for that, it's going to be a mismatch. Second, security and compliance validation. I always review AI generated architectures for vulnerabilities and compliance gaps. AI might miss something specific to retail PCI compliance or suggest a configuration that doesn't meet the security standards. Third, the cost reality check. AI might suggest an architecture that is technically optimal, but financially unrealistic. And we saw it here when we were talking about need for multi-region versus multi-AZ, and really kind of showing the optionality both from a technical and a cost perspective. Fourth, that feasibility analysis. can the customer actually implement this? Do they have the skills? Do they have the timeline? Do they have the organizational buy-in? If the answers to those are no, then we probably need to think about the architecture a little bit differently. And fifth, the value alignment. Does this architecture solve the customer's business problems? Sometimes AI cannot optimize for technical elegance when the customer just needs something simple and reliable.
No, this is great to know. So you're stress testing everything AI recommends against real world, correct?
Exactly. And this is where your knowledge as a CSM is invaluable. You know David's risk tolerance, you know the team's capabilities, and you know the political dynamics. For example, we showed it earlier. AI recommends Aurora Serverless for its database because it auto scales and is cost effective for variable work nodes. Technically sound. However, if Tech Retail's DBA has 10 years of Postgres experience and is uncomfortable with serverless databases, I'd recommend Aurora Postgres with standard provisioning instead. Slightly higher cost, but lower on the organizational risk level.
Yeah, so AI gives you options, but you make the final call based on the full picture, not just technical.
Yeah, exactly. And I document why I made those calls in architecture decision records, which we showed the other day, so the customer can understand the reasoning behind each one of those decisions.
All right. So again, I know we talked about a number of aspects. So what would be the one thing you'd like us to take away from this?
Yeah, AI is an incredibly powerful tool for architecture validation and optimization. It can find gaps, identify performance bottlenecks, suggest cost optimizations faster than I ever could manually. I mean, you just saw we were doing it in real time here. However, it's a tool. It doesn't replace good judgment.
Yeah. So like you always say, right? Trust, but verify.
Yeah. AI gives me breadth. AI gives me speed. It can analyze more scenarios, check for more patterns, and consider more options than I could alone, at least significantly faster than I could alone. However, I provide the depth. I understand the customer's business, their constraints, their culture, their risk tolerance. Together, we deliver architecture that are not just technically sound, but they're right for the customer.
Mm-hmm. I like that. So speed and breadth from AI and depth and judgment from us.
Absolutely. That's the partnership. Now let's go validate that tech retail architecture and make sure it's ready for production.
Yeah. So again, just to summarize what we took away from this conversation is, right, we definitely validate security and compliance. Reliability and performance is important, and cost is top of mind for every customer. But the important thing is, right, the validation framework, and as you saw, right, humans are there to add that, that validation, the important steps. So the human AI partnership is critical here, and ultimately, it's all about trusting, but we verify. Correct?
Absolutely. Yep. That's how I do my work now.
Wonderful. Wonderful. Thank you, Jeff.
Thank you, Raj.
Thank you. Amazing. Yeah. Another power pack session. Jeff and Raj, thank you so much. This is really useful. And again, there are a lot of comments on the chat which we try and answer. On the setup, also, a few people again have the question on your setup that they have. And answer to those is that Jeff shared it in detail in the last session, and it is also there on the Notion page. So please go through the previous recording and the Notion page. You would be able to find the entire information. So yeah. And Jeff will be updating the Notion page with this week's deck and the prompts also. I have also updated the same on the Tech Creator platform. So if anyone is using the Tech Creator platform, now you'll be able to find the recordings there, and all the things that are there on the Notion page are also updated there on the Tech Creator platform. So yeah, multiple ways to access the same information. I know it's a quite in-demand information, so you have it from multiple places.
Yeah. Please, everyone, go check out that Notion page or link in Discord. It has it for those of you who missed last week. It does have the information about how to set this up in there. everything that we use today in the demo here, and I have it up here, is from the setup from last week. And I just kind of called this back out again. Raj, others, Prasad, I hope you can see this up here in the top.
Hold on, let me put it. Yeah, now it is. Yep.
Great. So everything that we did today, the building the knowledge base of what the architecture is, and then the 5 prompts from the conversation that Raj and I have, $3.24 worth
You
of
might have to
agent
zoom in
compute
a
time.
bit, Jeff. Let's zoom in a bit on that if possible.
Hold on.
Yeah. There you go.
So, a couple dollars, and I got very quick answers and with my agentic partner that Raj and I can then iterate on before we go back and talk with our customer.
Yeah. Awesome. So with that, we are again 5 minutes early, and Anmol, you are up. Let me add you to the stage.
Hi, everyone.
Hey, awesome. So with that, thank you, Jeff and Raj, so much. And
See y'all.
we will be waiting
Yeah.
for the next week also for the behavioral section.
Take care.
Bye.
Just a minute. Yeah.
Let me add your screen. So in next 5 minutes, everyone who have actually registered for the slot 1, they would be getting the email with the access code to do the workshop, and it will be open for 10 hours. So you would have ample time to do the workshop. For who have registered for slot 2 and slot 3, you would be getting the email half an hour before your slot time starts. And again, you will be having access for 10 hours. So yeah, so you would have ample time. And if you have registered, you will get the access. And for any discussion, Discord will always be open. Anmol has also recorded the video, which will go live in next 5 minutes. But here he's going to walk through you to get you started, and also talk about some of the places where you might be stuck. So yeah, do listen to him. With that, I'll hand over to Anmol.
Thank you, Prasad. Hi, everyone. This is Anmol. I will be walking you through today's workshop for week 5. Today, we are going to build simple GenAI tools with the MCP, what we have discussed earlier in the session. So as you can see,
very quickly, increase the font size a little bit. Yeah, perfect. Thank you so much.
Got it. Okay. So yeah, the page you are seeing on my screen is the page when you click on the link which you got on your email. Once you get into this page, you have you will see all the information related to your workshop, your title, description, and get started button here. It is also on the left hand side in the navigation panel here on this page. Your AWS information, account information, which is your console access, your CLI credentials here. If you go a little bit down here, scroll down, you will see 2 events output in this workshop. So one is your password and another is your workshop URL. Once you click on this URL, it will open up your VS Code editor here. I already provided the password, which is present here. So first it will ask you for the password, and then once you provided the password, it will open up the VS Code editor over there. So let me walk you through the workshop. I'll open it into a different tab here by clicking on this Get Started button. So once I clicked on that, it will just bring me here, as you can see on the left-hand side with the workshop. So in this page, it will give you a detailed information about, what is MCP, why we are doing this workshop, what you're going to build, where you're going to work and all those stuff. Here it says about the complete set of AI powered productivity tools which you are going to work today on this workshop. This is like smart calculator, calendar assistant, weather advisor. And in the last, you are going to build your own MCP service. So All the things are provisioned for you. This is AWS event workshop. So for the next step, we are going to go on the workshop setup. Okay, so I'm clicking on this setup and environment section here in the workshop module, and here it is providing you a detailed information. There are two options for this workshop, how you can implement it, how you can do it. Since you all are part of a bootcamp, and you, like, whoever is registered for the event, they got their email and the access code. We are going to choose option A, that is AWS event workshop. There are two parts in each event. So like for this one, first is your infra setup, that is going to be the on the first one, and second is your application setup. I will be going through that. If somebody wants to do it on their own account, there is another part too. They can go for the self deployment, and this particular part will cover the self deployment. It is very easy and straightforward. There is a cloud formation template, and you just need to run that one. I'll go through it that too. Okay, so first I'll start with AWS event. That's what we are going to do right now. So once we have the AWS event, right, we already discussed the landing page. So as you can see here on the red highlight on the red box here on the left hand side, you will see your account access code and account access details. And on the bottom of the page, you will see the workshop URL and the password. It is just telling you about this on the left hand side and on the bottom of the page. Once you hit that, you're going to open the VS Code code editor over there by clicking on this URL and providing the password. So once you open that, it will come up like this. So this is your VS Code editor for today. So it is just asking you to, guiding you towards that step where you're going to provide the password. And then this is the VS Code editor, as I shown you on the other tab. So this is the completion of the first step, where you got your VS Code editor, you're good with your infra, and then we are going to move towards the second step, that is going to application setup here. So your application setup, it is on this particular table. It is providing you a brief, information about the workshop code. So there is a workshop directory in that particular VS Code. It is already preloaded. All the Python environment is ready. AWS CLI is already authenticated. Bedrock access is already enabled for that. Okay. Now, navigate to the workshop directory, and I'm just copying this command and pasting it here so that I can verify I am in the right place. So you see, these are the outputs I got here, and if I go here, it will show you the same. So this is the output you should get when you run this command. It is just going to that workshop directory and listing the content inside it. Okay. And it is giving you, pre-installed tool in this workshop, which we are going to use. You don't need to do anything. It is already pre-installed. It is already there and ready to use. AWS service is already configured in this workshop: Amazon Bedrock, CloudWatch, Secret Manager, EC2, and VPC. So everything is configured. And it is right now, it is explaining you the workshop application structure. So we have this workshop directory in the VS Code. Inside that, we have UI. Under the UI, we have front-end application, backend, start script, and stop script. There is a README file and requirements file too. We can skip this part. We are anyways going to cover it in the coming lab. So this is the part where you're going to launch your application. So once you are inside the workshop here, right, you're going to copy this command, right? And what it is going to do is it is going to execute the start script. So after running this command, it will execute the start script, which is inside the workshop directory here. So once you run it, like I already ran that command and it is already up. So you should be seeing like this. And also, once you executed it, there will be two servers which will come up, right? The application where you're going to access your application. So you should be seeing this output once you run once you started the script. To access your application, you see there is a port. If you go to your VS Code editor, there is a terminal. So earlier also, like maybe you guys have some side window with this. Like usually it comes like this, so you just need to, you can just cross it out because you need some more space on the screen. And this is your terminal, right? On the right hand side, there is a section called port. Once you click on the port, you should see two forwarded address, which is active on the port 3000 and 8000. When you hover over this particular link, you will see these three options. You need to click on open in a browser. Once you click on this one, it will open up your application. This is the application you should see after running the script and clicking on the link here on the port section. So once you see that, this is the application you will be using to complete today's workshop. Everything is there. Like you're going to use two things: your VS Code editor and your application, which is already there, and it is up. Okay. So in coming, like when we are scrolling down, it is just giving you a brief intro, like about the application. So left side of the application is the navigation panel where you will see your MCP servers listed. The toggle buttons over there, I can show you here. Okay. So these toggles button are used to turn on and turn off this MCP servers. When you are going to create your custom MCP servers, you need to click this toggle button on, so that it can interact with your custom server, and you can turn it off, like just to play around. Okay. Center is the chat section where you can interact with your application. This particular part you can see here. You can enter any prompt here. Right side of the application, it's a server log. So when whatever it is doing, like like it is showing you the logs here. Even if you are going to turn on or turn off the MCP server, it will log the session here, and it will give you that, hey, this my custom server, this is enabled right now. Also, please patient with this toggle. It takes a second or two to reflect here. So just click once and leave it like that. It will turn off or on. After that, once you do that, you are good with your application setup. So workshop setup is completed. Your AWS event, your infra is up, your application is up. You have access to your Visual Code editor. Now, if you go further in this workshop, there are three sections in this workshop. So the first part is going to cover the MCP fundamentals, which we already discussed in the session. But here it gives you more information, or like if you want to go through, I would highly recommend to give attention here and go through everything, this fundamental, the protocol overviews. So it talks about what is MCP, what is the key benefit of the MCP, the communication flow, which we discuss on our workshop today, today's sessions. The message type, like how, like if the MCP is going towards the tool discovery, what kind of request it is doing, what kind of response it is going to get from the tools over there, the tool execution steps, process, like the request call and the response call over there, and the transport method, STDO, HTTP, WebSocket, and everything. there is a section where like it is just providing you a sample that how it is doing the error handling, a sample code for the schema validation and the integration with AI models. So go through this. It will give you a really nice understanding about the MCP, and it will help you clarify any questions over there, or you can always reach out to us. So after that, it talks about the key MCP concept. Today it is going like it will give you a guidance to work with the fast MCP framework. So like under the MCP, we are going to use the fast MCP library for this one to calculate it, to create it, right? So in this section, it will give you a brief, provide you the concept for the fast MCP framework. Once you scroll down, it will give you the communication flow. So in this particular one section, it talks about the calculator. I'll show you later. Like in the next step, it will explore the code too. So it talks about the communication flow for the calculator. It will show you the code later on the next step here. And it is just providing you the flow, how it works over there, and what are the testing strategies we are going to use for our calculator. Like the calculator MCP server, which we are going to make in the next section. So here comes the code. Here comes the hands-on part for the first section of MCP fundamental. So after you have gone through the MCP protocol overview, key MCP concept, you should have a good understanding about how this thing works, the sections of the code where we need to define, and what section is belongs to which part. So after that, it talks about the code of the calculator. So let me show you. You can access the code here in this particular location in your VS Code editor. So once you go here, inside the UI backend, there is a directory called MCP servers. So inside the MCP servers, you will see all the MCP servers you are going to work with. And the first part it is talking about, you see UI backend MCP servers and the calculator server.py. So this is the Python file for the calculator server. You can look into this code and see like which function is doing what, how it is using the fast MCP to define this function, and create this new MCP server with the different functions here. So once you are like, it will walk you around with your VS Code, explore the code in the code which is provided on the directory over there for the calculator. So this is the short snippet of that particular code, calculator code. And then it will explain you section by section, like what this particular code means, like what it is going to do, how it is going to work, and all those stuff. So these all are there. Like this is the code snippet, and here below is the explanation of it, everything. So it will give you a really nice information about it. Now it will, like, once you understand all this stuff, you are going to go over your tool here. You already have the MCP server turned on here, weather and calendar. You will just test it out with some of the command. So like basic math, percentage, complex, and error case, it is already there. It will walk you through that. And also down below, you can enhance the calculator by adding some more mathematical function by providing these functions over there in the code here. You can play around, take your time, understand how it works, so that you have a good understanding of it. And like all this stuff, like you can add like context awareness to it and all those stuff. So just debugging tips and everything, debugging information, and all the individual function and the best practices down below. I have gone through it multiple times. there is no issue on this part. Just follow the workshop step by step, and you should be good on it. This first part is mostly for the fundamental and understanding the MCP concept. So the next part is the productivity tool. It will walk you around. So first part was, like, it explains the fundamental and it works, like it provides you the example of calculator. Second part, it will go with the calendar integration, weather integration, and multiple tool workflow. So it will walk you through the calendar code, the code for, like, the MCP code for the calendar, MCP code for the weather, and it will go you a nice workflow that how these multiple tools work together to give you an outcome for some prompt which needs a different kind of MCP servers over there. We'll see in the coming sections here. So I'm just going to the next one, which is the calendar integration. So it talks about, in this section, it talks about the calendar server feature. So what kind of function is there? Create event, list event, check availability, delete events, right? It gives you the location for the code to see, like if you like you want to explore the code for calendar, right? You can go here. It's the same place under the MCP server. You can click on the calendar and you can select the calendar MCP server for the calendar. You can go through this code. It's a pretty long, but give it a try. Go over it, and after that, it provides you the key feature about it, like what kind of feature we have in the calendar for this particular code, right? The conflict detection, smart time suggestion, and then it will ask you to test your calendar too, in the same way how we did for the calculator. You go here, you will see that your calendar is turned on, and then you can provide the prompt. I already tested it. Everything is there. You can play around it, do some modification in the code, and everything. It will work over there. So after that, it will give you some prompts for the complex scenarios, and provide you some more information about the code and error handling and the best practices. So similarly, it will walk you through the weather server capabilities too. There is another MCP server for the weather. It provides you the, like, function implementation overview, the code overview, right? So you can find your weather here under the same MCP server directory. This section here, you find the code for the weather MCP, and then it provides in the same manner how it provides you the calendar. For the calendar, it will ask you to go for to test the weather server with it gives you some query to do that, and provides you, like any kind of error handling, common coordinates example. Like these are some examples, like for the Seattle, New York, and anything. Okay, so now on the last part of this particular module, it will give you um, a high level overview, like how it works, the flow, right? Where you have your like you're giving a prompt to your application, how these three MCP servers do, like, work together, figure out and provide the outcome. So it provides you that information, like the workflow here, and with a prompt to do that. You please feel free to use any different kind of prompt to play around, which can include all these three MCP servers, so that you have a better idea. So now these two parts are completed. One is like MCP fundamentals, second is productivity tool. In MCP fundamentals, we have gone through the fundamentals concept and the calculator as an example. Productivity tools, it provides you the calendar, weather, and the multi-tool workflow, how these three tools are going to work. In the next one, this one, you're going to build your own MCP server with a fast MCP, right? It will give you step-by-step process or implementation steps where it provides you the instruction, like what are the things you need to consider, what are the important things you need to pay attention to when you're working on building your custom MCP server. So in this one, it talks about the design, implement, test, deploy, and validate. We also provide you some kind of server ideas for the custom part, right? So there are already a pre-configured server idea, like pre-suggested server idea. So one is for the URL shortener, another is password generator, and third is the unit converter. So these are some ideas which you can work on, which is already suggested here. Again, it is providing you the current file structure. I'll show you where you're going to put your put your code in the directory, in the file. So you see under the MCP servers, you have the calendar, weather, and the calculator. You should be seeing a custom directory too. Inside the custom, you will see a file name called mycustomserver.py, and here you're going to provide your command, like your code for your custom MCP. Once you find that, these are it is talking about the same thing, the implementation template which we saw over there, the my custom server py, and there is already some code over there here. I think I changed something. Yeah, no, it is the default one. So it is giving you some guidance like custom server, URL shortener, and all. Okay, so you will play around with that. Here it talks about the step-by-step implementation, like choose and design, and what are the steps you are going to follow to work with your own custom MCP servers. Now, if you go down here, once you provided your code in your custom MCP file, you need to turn this toggle on for my custom server here. So this is very important. This thing, once you provided anything over there, any kind of code over there, then you need to turn this thing on. Then you can interact with it and see how it goes. So there is no, you don't need to manually restart the application to sync the changes you are doing in your code. It should be done automatically. If there is any need, you can follow this step, but I have done it several times. I didn't need to do that. And if any point of time it doesn't work, we are here to help you out. Okay, so this is just an example. It is giving you for your for the URL shortener. It is giving you step-by-step detail what you need to follow and everything. So you can just follow this. Okay, and here you can see the complete code for URL shortener. So suppose if you want to try all three ideas, right, which is provided in over there, so you can try it out by we are also here. It also includes the full code for your URL shortener, password generator, and one more. There is one more thing, that one too. Okay, so this is where you build your custom MCP. Just provide all the codes here on this particular file, and you're good to go. Once you're done with that, we are moving towards the next part where you're going to host that MCP, host your MCP on the agent core. This will follow, this will guide you. This step will guide you to do that. It talks about why agent core runtime, how agent core works, pre-built file. So for the agent core, there is already pre-built file in your VS Code directory, VS Code editor over there. It is under in the same directory. You see the agent core. You will find all the files related file here. Okay. So now, okay. So again, you're going to execute these commands on the VS Code editor, right? So maybe like you guys already know, but I'm just telling you that once you start the application, right, this is what your terminal will look like. So to execute the other commands, I just create a new, like add a new terminal, and provide this commands over there, so that it will not interrupt the ongoing process over there. So I'll just execute all the commands which are provided here in the new terminal, this one. Okay. So you just need to run this, and this is just for seeing the code. Like you can also explore through the VS Code editor, that is fine. And then you need to install the agent core toolkit, and then run this deploy agent core. Okay. So once you run, you should be expecting this, that the deployment is completed. Okay. The next step is to run this script. So once you run the script, you will see that the configuration updated successfully, and you should be seeing it on your agent core runtime in your AWS console. So you can also click here and access it. But what I would recommend is you will get to this one. You see on the left hand side AWS account access. So you can just click on this. It will open up here. So that just to make sure that you are using, like you already logged out with all your previous previous account, or the personal account you're using for the AWS account, and you are on the right account to check that the thing is uploaded over there and it is there. Okay. So you go there, and now either after going into the AWS account, you can do anything. You can either click on this one. It will directly take you to the Bedrock. So here you need to go into runtime, this one. Under the build, you need to select the runtime, and in the runtime you will see this particular thing, this particular name, text utils MCP. This is where it is going to host. Usually, like when you click on that link, it usually comes here on the home page, but you need to select the runtime, and in the runtime bottom of the page you will see this resource here. That is all for this part. And then once it is hosted over there, to enable that, you have to go to your application. And similarly, how we enable my custom server, right? You need to toggle on this text util remote, like this one. The stand agent is also there, but we need to turn on this one. It is also in the workshop here. It will guide you towards that. And then after you turn it on, you can play it around, and it is giving you the the information about how it works, the transport protocol, local server, remote server, all those things, and the operation about the monitoring and updating about it. So you can just tail the logs over there and everything. Okay. So next step, this is optional, but I would highly recommend to go over it, like try it out by yourself. It is a stance agent, like we did it earlier, but like this one is there. It is optional, but give it a try since you have the workshop. Utilize it to the fullest and give it a try. And yeah, and then that is all for this workshop. You should be it is pretty straightforward. You should be good. There is no catches here. Everything is working. We tested it multiple times, so it should be good. It just talks about the summary. It will give you the summary and the next step. For the cleanup, you can just run this command, this particular command. So remember, we started the application by start script, and now we are stopping the application with the stop script. So this will do the work, and it will stop the application over there.
Thank you, Anmol. We are almost on time, and on few of the volunteers have already tested it, and there are some issues and resolutions link that I've pasted on the YouTube. We'll also share it on the Discord in case if anyone is stuck. But thanks, Anmol. Anything else to cover?
No, we are good. We're good on this.
So if you can go to the home page, I just want to show one thing to here. The very first one.
Here.
No, on the workshop page, main workshop page. Not here. Let me share the screen. Give me one moment. It will be easier and quicker. So the only thing I want to emphasize, it shows us a 2-hour learning path. We do provide you for 10 hours. Take your time to do these sections. So every section has how much time it's going to take. Right? And especially when it comes to build your MCP server, custom server, easy is to copy paste the code and then get it running, right? But instead of doing it in 30 minutes, probably take an hour or two to try and see if you can build a smaller one. And if this complexity level is high, then choose a simple one. Try and build the calculator on your own if you would like, right? So, but try and see if you can build. And I know a lot of people are afraid from programming. It's nothing to be afraid of, especially when there are so many AI agentic tools. And next week we'll be covering Kiro, which will help you like do the whole development process much easier. It's nothing to be afraid of. So try and do a bit more hands-on in this particular workshop. And as you see, every week we are trying to incrementally increase not only the complexity but the conceptual concepts, right? So we'll keep on adding that. So take your time to do the workshops. That's pretty much. And let me add the other folks who are still with us. Nisha, I can see you. Let me remove the screen. Okay, and then who else is there? Vijender is there. Yeah, Vijender, thank you so much. You and Anmol have been answering the questions like anything during the technical session. So thank you so much for doing that. Cool. Any last comments from anyone?
Thanks everyone for joining, and just follow the workshop step by step. Try to understand what it is doing rather than just finishing it. I think that is the key here, and that will help you understand the concept better.
Yeah.
Yes, for sure.
Awesome. Thank you so much. Have a great weekend, everyone.
Thanks
Thank you.
everyone.